All right, so we're going to start talking about ratios and proportions today. So let's go ahead and fill in the blanks up here just so we have some of the definitions. So a ratio is a comparison of two quantities. To simplify, we find the greatest common factor for each quantity and factor, which means divide. Sorry, I was trying to figure out which word I should put in there. So we're going to factor it out or divide it out. So this is if we have anything to simplify. So if I said, if I'm comparing the numbers 3 and 9, for example, this is a ratio. This is a comparison of two quantities, 3 and 9. Well, they can both divide by 3. So I can say 3 divided by 3 is 1, and 9 divided by 3 is 3. So I can simplify this ratio of 3 to 9 to 1 to 3. It's just a way of simplifying. So we're going to practice that down here in just a moment. And then we can also solve a proportion because a proportion is a ratio equaling a ratio, which actually we'll look at right here below. And we're going to use cross multiplication. And what this is it actually helps us get rid of the fractions. Multiplication, sorry, to focus on writing my words there. So we're going to do cross multiplication. So we can see here's a fraction equaling fraction. So I have 2 over x equals 10 over 13. This is what we call a proportion. So we're going to multiply from numerator to denominator going across the equal sign. So we can follow the arrow. It's going from 2 to 3. So it's going from numerator to denominator. And it's going to cross that equal sign. And this is done twice. Because I also have to go from 10, this numerator, to this denominator. So I have to go from both numerator to denominator across. So, and the resulting numbers will be equal to each other. So we're going to go 2 times 13. And that's going to equal 10 times x. And really what we're doing is we're very quickly eliminating the fractions. We're not changing the equation yet. Actually, we're not really doing anything to solve the equation quite yet. Well, that's not true. We are solving the equation, but we're doing a very quick action. So what I'm doing is I'm taking 13 and I'm multiplying by both sides because that cancels the 13 and it brings it over here, which I have 2 times 13. And then I would also do the same thing with the x. So I'd multiply by x on both sides because that would cancel this x and it would bring it over here. So I'm doing that very quickly with this cross multiplication because that's how we would get rid of the fraction, is to multiply by the denominator. So instead we just do that same idea, but we call it cross multiplication. So 2 times 13 we get 26. 10 times x we just write as 10x. And then to get x by itself we would just undo that multiplication by dividing. So we divide by 10 on both sides. And we would get 2.6 equals x because it's a decimal here. It doesn't go in evenly. So this is the idea. We're going to use this a couple of times. So first, let's talk about that idea of simplifying a ratio. So simplifying a ratio of whole numbers, problem type 1. So we're going to write the ratio as a fraction in simplest form with the whole numbers in the numerator and the denominator. So they do want us to write a fraction. So instead of 40 years to 72 years, they want us to write it as a fraction like this. We're going to simplify it because these numbers divide by the same number. So we can say, what is the greatest common factor of 40 and 72? So you can go through the list for all of the factors of 40 and 72. So 40 would be 1 and 40, 2 and 20. 3 doesn't go into 40, but 4 does with 10. 5 does with 8. Let's see, 6 does not go in, 7 does not go in, and then 8, we're back to 8. So now they're not quite in order because I did them together, 1, 42, and 10, 20. And then I can do the same thing with 72. So it would be 1 and 72, 2 and 36. 3 does go into this one, so 3 goes in 20, let's see, 4 times, 24 times, because it goes in twice here with 1 left over and 4 times for the 12 that's resulting. And then it does go in 4 times. So let's see, that would go in once, with 32 left over, which would be 18. 5 does not go in. 6 does. I know 6 does because both 2 and 3 go in, so 6 will also go in. So 72 divided by 6 is going to be 12. Nope, did I do that wrong? Sorry. Goes in once. Yep, 12. Okay, I did that right. Because we'd end up with 12 here, and then 6 times 1 would give us 6, plus 1 more is 7. All right. 7 does not go into this one. The closest would be 70. So I know 7 doesn't go in there, but 8 does go in with 9. So, and now the next number would be 9. So that's all the factors of 40 and 72. So it takes a minute to write down all of these factors. So the greatest one that's in common, let's see, because I can see they have 8 and 8 in common. Let's see, is there anything bigger than that? I think 8 and 8 is going to be the biggest thing they have in common. Yes. So I can go through and I can divide by 8 and divide by 8. So with this one, if I just go back to the list of 40, 8 and 5 is what made 40. So 40 divided by 8 is 5. And then 72, that was 8 and 9. So 72 divided by 8 is 9. So I can kind of quickly reduce that. But if you don't go through the whole list, you don't have to do it this way. You could do it in smaller pieces. So I could have done 40 and 72, and I could have divided by 2 because they're both even. So that's perfectly fine. 40 divided by 2 is 20. 72 divided by 2 is 36. Well, they're still both even, so I'm going to divide again. 20 divided by 2 is 10. 36 divided by 2 is 18. Oh, they're still both even, so I'm going to divide by 2 again. 10 divided by 2 is 5. 18 divided by 2 is 9. So if you notice, I end up with the exact same answer, either method that I use there. This one just takes a minute to go through and keep dividing, but so does this one because I have to list all the factors or know the greatest common factor that can divide into both. So the more we know our multiplication, facts, that makes it a lot easier, and we might not have to go through and list all of these to know what they would divide by. But that's not necessarily a huge skill that we push for memorization anymore. Although it does make things a little easier the more multiplication facts that you have memorized. All right, so now we're going to go ahead and we're going to look at a proportion. So we're going to solve a word problem on proportions using a unit rate. So we have Heather drove 660 miles in 12 hours. At the same rate, how long would it take her to drive 495 miles? All right, so we're going to set each fraction of the proportion as miles per hour. So I have miles and hours. So they told us she went 660 miles in 12 hours. That's my first part. That's my first fraction, my first ratio. And then the second part says how long it would take her to drive 495 miles. So since I've decided it's miles per hour, I need to make sure I put the miles on top. And the hours is what I'm questioning. So I can use any variable I would like. I'm going to go ahead and use H. I'm not sure why all the words have been smushed together here in the sentence. But the second fraction will have a variable, just like we see this. It can be any variable you would like it to be. And now we're going to solve using cross multiplication. So I'm going to cross. So it's going to be 660 times H equals, and then I'm going to cross again, 495 times 12. So now we want to make sure that we use, and I believe Alex would give us a calculator on this one, but we can do this without a calculator as well. You know, we can always set this up with multiplication, and I can go 5 times 2 is 10, we get 18, 19, 8, 9, this is 5, this is 9, and this is 4, so I get 0, 14, 19, 5. It sounds like there's a big truck right outside of the window here, so I apologize if that's loud. So we get 5,940. And then we can divide by the 660 because we want to undo that multiplication, so we're going to divide by 660 like this. So anything divided by itself is 1. So I have H equals. So now with this one, we just want to divide it down. And I'm going to have, let's see, So I'm going to cross this off and let's see, how many times would this go in? So it doesn't look like, well, okay. So let's see. If we have 66, that's going to go in almost 6 times. So let's see what 66 times 6 is. So we get 36, 36, 37, 38, 39. So 390, so not quite. So let's do another 6. Let's see, we get 12, 15, 16, 4. Oh my goodness. That's a very loud track, whatever that is. All right, so 6, 7, 8, 12, and 5. So we're getting closer. Let's see. So now we get 14, 6, 7, 8, 9, and 5. Oh, look at that. We landed right on top of what we wanted to land on. So that was 6 times, 7 times, 8 times, 9 times. So I kind of did a little guessing there, going through and doing that, but I can see that it took 9. And since that represents hours, it's going to be 9 hours. So, and again, I believe there is a calculator on Alex. This is probably something that I would definitely let you have a calculator for in class. I'm just showing it's 100% possible without a calculator. All right, so we're going to solve a proportion. This one's already set up for us. We're just going to go ahead and do the cross multiplication. So we're going to cross. So we have x times 8 equals 6 times 12. So we get 8x equals, and 6 times 12, that's 72. We had just done that one up here, right? And then I'm going to divide by 8 on both sides to get x by itself. So 8 divided by 8 is cancels out, and I have x equals 72 divided by 8 is 9. So by chance, we ended up with 9 on both of these. Total coincidence. It's not always going to be 9. But that was our introduction to simplifying ratios and solving proportions. So go ahead and go on Alex and give that a try.